Thank you. So I think, as we've seen in the morning session, that chemistry is playing an important role in solving a lot of the scientific challenges that we have today. Whether we're talking about energy and materials, like Colin was talking about perovskites this morning, there was a lot of talk about proteins and DNA, trying to understand biology on a molecular level, or whether we're trying to find greener alternatives for important industrial processes, like the Haber-Bosch process that Flumel was talking earlier. And I believe that in today's digital world, computational chemistry can help us find solutions for these hard problems, and is a way to get a lot of people involved without having to buy expensive chemical equipment. But there's a significant barrier to entry to just anybody trying to use computational chemistry. Traditionally, these high-accuracy calculations require large supercomputers that only academic groups or national institutions have access to. And the output is not user-friendly and requires users to become computer experts in addition to learning the underlying math and physics. I'm trying to tackle the first of these by developing a cloud-based platform where users can rent hardware from Amazon and Google and Microsoft to run these calculations themselves. But I think actually the most exciting thing that I'm going to share with you today is the interactive simulations that are enabled by this sort of software. So you can think of interactive molecular dynamics as a real-time molecular movie where users can reach into the simulation and push and pull on atoms and have the molecules break bonds and do chemical reactions with full quantum mechanical accuracy. You can imagine a undergrad in organic chemistry given this reaction, and then given a molecular playground where they can learn the rules of chemical reactivity for themselves without having to resort to memorization out of a textbook, or say even families in a scientific museum can be learning this sort of chemistry just right there. And recently, we've also been using virtual reality and showing molecular orbitals as a way to show what the electrons are doing in real time so that we can finally start to get an intuitive understanding of what is happening without having to be an expert computer user or learning all the math and physics behind this. And I hope this will lead to the gamification and democratization of quantum chemistry, and that's how I'm breaking the wall